Now, one last point before we go to more derivations for the mass energy equivalence, and I promised to show you at least 4 or 5 different derivations of how to derive the mass energy equivalence relation. But now, since we are speaking here about supersymmetry and the vacuum and the void, one of the big problems in the standard model is what is the origin of mass, because according to the calculations of the different levels of symmetry, different symmetry sets in the current standard model, we get the different particles and symmetrical generations of particles. We get them through rotations and transitions or translations from points or bosons which are have zero mass. Only we find practically that particles have mass. We cannot really get or find the mass of particles without knowing them experimentally. If you go through the theory, you will get only zero mass particles. So to explain the mass of particles, how can we get masses for some particles, which are the fermions, we have to use this Higgs mechanism based on the spontaneous symmetry breaking, and this is actually successful relatively, but it's still this same model cannot really explain why the Higgs itself is actually very, very heavy, as you already may know. So this may explain how some particles can gain mass, but how the Higgs itself got its mass is not possible. However, in the duality of time, because the vacuum is superfluid, and let me remind you again why it is superfluid, because if you have CV as a normal state of matter where you have internal creation at C and imaginary motion at V, so if you want to get to the state of vacuum, you have to reduce this V absolutely to zero, not only as external velocity, but as any vector velocity of the components of the particle or the object, and therefore this will be identical with zero temperature, which means that absolutely we have no interaction in this medium, which is a state of vacuum. All its points are identical. They are indistinguishable because they don't interact with each other, and therefore this is a Bose-Einstein condensate. This Bose-Einstein condensate describes the state of a superfluid or supergas. It's superfluid for C0 and supergas for 0C. They are actually equivalent, but they are orthogonal to each other. So if you believe that the vacuum is a superfluid, you will be able to understand, or you can derive how some particles can get mass. Already we have some mechanism for this, like for example in superconductivity, which is known for many people, but now I want to skip this, because in this duality of time theory we have an even deeper and more profound principle of how to get mass, where the mass is coming. Even without this idea of superfluid, we have a very basic principle even from classical mechanics, because classically the reason of inertia is the delay that we get when we have when the interaction moves from one part of the object to the other part of the object. And because this delay, this interaction cannot be higher than the speed of light, so we need time to raise any object or to move any object. And from here we get the inertia. So this means that any object must be composed of particles, and these particles have smaller masses, and every one of these particles have components with smaller masses, until we reach a point where we have smaller subparticles which have no mass. This is not known now in the current physics, because we stop at some points. We stop. For example, we believe that matter is composed of atoms, and atoms are composed of protons and neutrons and electrons, but we cannot go further, at least not further than the quarks, for example. But according to this duality of time theory, ultimately any object is composed of monads, and the monad is a point of space. So if it's a point of space, it has zero mass. It's CC, for example, or C0. So it has no motion. Only we get motion and we get objects when we combine monads together. So when you combine many monads, you get objects. So every monad have zero mass, but when you combine them, you get mass. And the reason why you get mass is because you cannot create two monads at the same time. Remember that this duality of time is based on the idea of the single monad. And the single monad model means that we have only one monad creating everything. So this monad is appearing in one state and then going back to vacuum and appearing in another state, and so on. So at least we have two monads. These two monads cannot appear at once. They need to, the monad need to disappear or go back to vacuum and go back again to, from void to vacuum and from vacuum to void at least twice to make the minimum object composed of two monads. But of course, this is a minimum case, maybe for neutrino, for example, or even other lighter particles. For higher particles such as protons and heavier, we have maybe millions, or I don't know, maybe actually comparing between this cosmological discrepancy or the number that we got in the previous slide, which is 10 to 120, comparing this number to the number of particles, which is the Eddington number in the number of particles in the universe, the difference between them is about 10 to 40. So I believe that the proton, for example, is composed of 10 to 40 monads, 10 to 40 points of space. So it's really a very huge number, and from here we get the mass. But the minimum that we can get is 2 points or 2 monads. So the reason why these 2 monads have non-zero mass is because they don't exist at once. If they exist at once, they will appear, they will come from void to vacuum, they will come in zero time, and therefore they will have zero mass. But the monad, the single monad, which is creating everything, need to go back to vacuum, void and come back again, and so on, to create every monad separately. So we will need time to raise this object from zero to any speed, and therefore this is the cause of inertia. Just like for example the piano. The piano key is the keyboard of the piano. So you click the keys one by one, and therefore if you click together, you will if suppose you click them all together, you will get one sound. So you can always produce one sound. If you want to produce a note, you have to click them one by one, and therefore any note or any piece of music will require time. And here the same, if you suppose these are the points of space, so if you want to move them, suppose for example you want to carry this object, suppose you want to carry it from here, you need to wait until these other points lift up, and therefore you get inertia. Suppose this is all one piece going together without any structure, you can lift it all together at once, and therefore you will need zero time. And this is true only for bosons, which are of the structure, in our case, of the structure CC, not C0. So they are higher vacuums, they are energy. But our normal vacuum, lower vacuum ground state is C0, and therefore we need velocity in order, we need imaginary time in order to move it, and therefore we have inertia. Okay.